Okay, so in the last video, you saw all of the different ways that we could describe our slope. I'm going to write them right now. We say delta y over delta x. Delta just is the Greek letter representing in science and math change in. So delta y over delta x means change in y over change in x, otherwise known as rise over run. And I'm going to add one more here, which is just to say y2 minus y1 over x2 minus x1. And these are all saying the exact same thing, which is just how much does your y coordinate change, and put that over the amount that your x coordinate changes. So the way that we find out how much it changes by is by doing this little calculation when we are given the 2 points listed like this. So that's what I'm going to do right now. I'm going to I'm going to erase this and simply leave us with y2 minus y1 over x2 minus x1, because that's what we need. And then we're going to identify which point is point number 1, which point is point number 2. So now we've got y2 minus y1 over x2 minus x1. How do we know what those values mean? Well, let's call this point number 1. That's point number 1. So therefore, then the x coordinate of point number 1 is x1. And the y coordinate of point number 1 is y1. That's where we get x1 and y1 from. Okay? If we call this point then point number 2, then we've got x2, y2. Okay? So the 1 and the 2 in these x1, y1, x2, y2 just indicates which point it's coming from. It's coming from point number 1. It's coming from point number 2. And then the x and y part indicates which coordinate is it, the x coordinate or the y coordinate. So we're going to take that information and I'm going to fill it in down below so that you can see how we do it, and then we'll simplify it. So as always, I want to put parentheses whenever I'm going to substitute in a value for a variable. And these are variables. They happen to have weird kind of notations to them because we're differentiating two different y coordinates and two different x coordinates. So they have the little ones and the twos on them. But we're still just substituting it in. So that's what I'm going to do. So once those are filled in, what is 3 minus 0? It is 3 over, what is 3 minus 0? 3. And what is 3 over 3 equal to? It equals 1. So this one has a slope of 1. And let's box it as our final answer. So that's the slope for the first one, number 17. I'm going to repeat the process for numbers 19 and 21. And you'll notice that in this one, I didn't write number 1 and number 2 over the points. I just wrote x1 and y1 under one point and x2 and y2 under the other point. You will eventually you will realize that we don't need to put number 1 and number 2. We just need to make sure that we know which one is x1 and y1 and which one is x2 and y2. So when I fill them in here, then I need to do is simplify it. So 3 minus 4 is negative 1. 5 minus 4 is positive 1. And remember, anytime that we've got a slope where there's a 1 on the bottom, we can just call it that whole number numerator or whatever it is. In this case, it's negative 1. So we've got a slope of negative 1 for number 19. I'm going to repeat the process one more time for number 21. So I've identified x1 and y1, x2 and y2, and here you see I've again rewritten the original formula, y2 minus y1 over x2 minus x1. Always a good idea to start with that, and then we put parentheses wherever we're going to be substituting in a value. So now I'll just plug in the values, and then I will simplify. On the top, 8 minus 1 is 7. On the bottom, 4 minus negative 6, that's the same as 4 plus 6. 4 plus 6 is 10. And actually, I'm going to write that over here because we don't need to simplify this. 7 over 10 is not going to be simplified, and so that becomes our final answer. And so we've got, for number 17, we've got a slope of 1. For number 19, we've got a slope of negative 1. And for number 21, we've got a slope of 7/10. And we're done.